Recording is rolling. It is Tuesday, February 11th. Now, I do have a bridge construction project for you guys today and for the next few days. Before I get to that, a little bit of follow up from yesterday. You guys remember yesterday I had a civil engineering presentation for you guys? I said I was going to bring this in. So here's something to say for my concrete class. So we poured these molds, concrete. You guys see, this should be about 4 inches diameter. And this used to be 8 inches tall when it was poured. So we had to wait, I think at least a week or two for that to cure and then put it in the machine and smash it, broken. Yeah, so I'll save that for my college days right there. You can see that. Right. Also, follow up from yesterday. I did mention that there was this self-healing concrete. Right, there's certain bacteria that you can embed in it with starch, and then if it cracks and it gets exposed to the oxygen, the bacteria wakes up. Right, but I couldn't remember what that was called. No, I know it was referenced in this book, so I found that on page 67. So the name is it's right there by my thumb. B. Pasteurie, something like that, right? I think I've seen another name too. I don't know if there's a different kind of bacteria that can do it, but at least that's one of them. And calcium carbonate is what it excretes, which will seal a crack in concrete. There you go. It's about yesterday. All right, so taking a few days to do this engineering project. You guys get to build a toothpick bridge. Here's an example model from a previous year. You guys can kind of get an idea. Okay. So your budget limitation is you guys got 100 toothpicks. There should be 100 toothpicks in a cup. You might want to count, make sure if you have like 95 or something, let me know. I can bring you up to 100 and glue. So that's it. That's your materials. 100 toothpicks and glue. You get a few days to put this together, Tuesday, Wednesday, Thursday. And then we're going to test these bridges on Friday. That's what test the bridges. Your goal is to span a 20-centimeter gap. So what I'll do is I'll set up some desks with a 20-centimeter gap. We're going to ruler measure 20 centimeters right here. Okay. Here, just for the camera here. Here's 20 centimeters span right there. Okay. Now, guys, do you want your bridge to be exactly 20 centimeters long? That's probably not a good idea. Do you want it to be 15 centimeters long? No, then you have a raft. Do you want it to be probably at least 25 or more centimeters long? Yeah, that would make more sense, right? Because then you got a couple centimeters at least overlap on each side. Right, so what I'll do is you guys set up your bridge to span your 20-centimeter gap. Then I'm going to take this roll of masking tape, which has a diameter of 9 centimeters. You see 9 centimeters right there. Okay, put that on top. Then I'll put that gray tray that you guys turn your work into on top of that. Okay, which is a little bit of weight, but not a whole. But then I start sucking these lab weights. Clunk, clunk, clunk. We're going to see whose bridge can hold the most weight. Okay. Any questions so far about that? All right, so you guys, of course, have your toothpicks and glue. Do all this work on pages of paper. And then I'm going to recommend that you maybe put the panels together today and glue the panels together tomorrow. You might need an extra day to go back and do some fixes, right? Right, so figure out what design you want to make with your teammates, right? And then how you're going to pace that out over a few days. Now, this one, you guys can see there's like little shreds of paper that got stuck on here, right? So the paper is not a construction material, but if a little bit gets stuck on there because you're doing all your work like on a paper, right, then that's okay. Just peel the paper off, just like this one, right? It's got a little bit there. Nothing too bad, right? Right. Also, of course, if you're doing your work on your paper, you write your name on your paper, and then at the end of today, put your work back on the lab table so that tomorrow you can pick it up and then continue your work, right? And for a picture of your name, it's on all your materials. Okay. All right, you guys good so far with all that? All right. Now, I do want to throw you guys a hint. Right. So, of course, the design is up to you and your teammates. So each team is making a bridge. Now, this bridge, if I look down the tunnel, do you guys see like a square-looking type cross-section, right? Rectangular-looking cross-section. So imagine there was a car that was driving through like that. Okay. Now, the one I drew here has more like a triangular type cross-section. Okay. Again, it's up to you exactly how you want to build this. But suppose you want a triangular cross-section type route, and you're comparing these two bridges. Right? Let's attach a story to this. Let's say there's this big old ravine in the middle of the woods, and you see a couple of bridges side by side. Right? You're going to drive your car through one of these, and you're looking at it, I don't know, these bridges look kind of sketchy. They've been deep in the woods here. They're like rotting away for years, and I don't know, is my car really going to go over those? Well, I really got to cross one of these bridges. So which one of these is able to hold more weight? That would probably be the better candidate to actually drive your car across. Which one holds more weight? If I start stacking a bunch of weight on this one where it's pretty flat, like horizontally oriented, and stack weight on top, or the one that's pretty tall and the toothpicks are more vertically oriented, right? Which one holds more weight? Okay. Do you guys think you got that figured out? Let me see, show of hands. What are you guys thinking? Okay, which one holds more weight? Okay, and of course, the other one's gonna crack and break first. Holds more weight. How many guys, show of hands, think the one on the left holds more weight? Who thinks that one? How many guys think the one on the right holds more weight? Ooh, yeah, that one right there. All right, there's my winner. It's the one on the right. This one holds more weight. Okay, so if you have your materials more vertically oriented, they're able to hold more vertical type force. What this was related to from last semester, do you guys remember that spring scale lab I had you guys? It was actually 10 mini labs, and one of them was had you guys hold the spring scale straight vertical and then start to spread them out like a Y closer to a T shape. Okay, you guys, when you did that, when you started vertical and went closer to a T shape, what happened to the spring force in these top springs? Going from picture on the right to picture on the left, it increased, right? Increased, right? Okay. For example, if you had see this 1 kilogram weighs about 10 newtons. If I was hanging this right here, clunk, I bet these spring scales would be pretty close to about 5 newtons each. You guys think maybe 5 and 5 or maybe 6 and 6, something like that, right? But when you spread it out like a T shape, doesn't it approach infinity? Right? So between here and here, it's gonna increase from the left. Okay? Right. Well, no, that's a tension example. Now, if you turn that around to compression, we're back to the toothpick bridge, right? So, say I put this 10 newton weight on top of this bridge here, clunk. I bet 5 newtons is going to distribute to the left and 5 newtons is going to distribute to the right. About right. Now, that's if they're exactly vertical, right? But say I put it more on this flat type bridge. Now it's still 5 newtons vertical transmits to the left and 5 newtons vertical transmits to the right. But now there's also these horizontal components in addition to that. And if you want to figure out the total compressive force built up in the toothpick, you could use Pythagorean theorem, or well, you could work your way around with trigonometry. Yeah, depends. Do you know angles? Do you know sides? So, all right. So that gets you guys going. All right, so you guys got a few days to build these toothpick bridges, and then, whoops, say Peter. Okay. Then we will test these out on Friday.